My name is Trevor Harrison. For those of you who don't know me, I'm a professor in the Department of Sociology here, also director of Parkland Institute, and it's my great pleasure to be here today to act as MC, I guess, for today's talk. Our speaker today, Mickey Vallee, last summer, he, as some of you know, he peregrinated from here. But far from that being his swan song, he has migrated back to us once again to give the talk today. Now, some talks are always directed at the doves, and there are other talks that are directed at the hawks, and then there are also some talks, as we know, that are also just purely for the birds. But we actually know that that will especially not be the case today. Earlier, Nancy asked if I was going to do a Russell Crowe imitation. I kind of like that. The title of the talk, which I'll come to in a moment when I finish making bad puns, does make me almost break into a W.C. Fields imitation here. My little chickadee, but anyway, I will refrain from that. Anyway, our speaker for the day is Mickey Vallee, who is an associate professor of cultural studies at Athabasca University Center for Interdisciplinary Studies, and also affiliate of the Prentice Institute, as am I. His research focuses broadly on intersections between sound, subjectivity, technology, and the politics of social change in the context of contemporary social problems. With the help of an Insight Development Grant from the Social Science and Humanities Research Council of Canada, he is currently researching how professional and volunteer researchers collaborate around environmental issues using emerging sound technologies and innovations. In addition to this, he is also researching and writing on the voice sciences as well as on rhythm as a sociological methodology. He is founding member of the Post-Humanism Research Network at Brock University and is hosting an international conference on the idea of place at the University of Alberta in celebration of the 20th anniversary of the journal Space and Culture. He's published most recently in the journals Theory, Culture and Society, Body and Society, and the Sociological Review, and will be presenting at the University of Bristol on the topic of animal utterances. His talk today is going to be the title Ecology-Chk-a-dee-dee-dee and Other Lines of Flight, the New Soundscape Ecology. Just before I finish off here, I do want to also promo, however, the Prentice Institute, some upcoming events here. On May 1st, Let's Talk About Men's Health. Steve Robertson, Professor, School of Health and Community Studies, Leeds, Beckett University, England, will be speaking. And finally, you will see a sign-up sheet here that if you have not already made yourselves known to the Prentice Institute, please take time to do that. So you've heard enough of me and my bad puns, so I'm now going to turn over to Mickey.
Thank you, Trevor. Thanks. Thank you. I'm working at Athabasca University in their Interdisciplinary Studies Center. And I'm looking at the contours between the natural sciences, the social sciences, and the humanities on new types of collaborative projects that are intended to contribute towards increased environmental awareness and protection and conservationism, and the bridging works that happen with that. So I'm working in between a lot of different projects right now. And I think there's only one chickadee in the whole presentation, which I apologize for. I think there are more ATVs and chickadees in the presentation, which leads me to thank Susan for having me, and the Prentice Institute in general, and my old colleagues, former colleagues from the University of Lethbridge. And it's nice to be, back. I know. It's nice to be back and out of out of my office for a little while to be talking with people, especially volunteers and people who belong to nature societies and birders who are here. I'm immensely interested in your birding, and at the end I have an email I'll display if you want to ever contact me and share with me your passion and interest about birding and where you go and what you learn. I'm taking in as much information and data as possible as this research project continues. But in terms of the kinds of sounds that we're going to hear today, I'm not going to be isolating natural sounds. I'm going to be looking at collaborative sounds. That's three types of sounds that we're interested in soundscape. And I'm no soundscape designer, nor am I a soundscape ecologist. I'm interested in them from a purely social science perspective, i.e. how are they used to better and identify problems in contemporary social reality. The three kinds of sounds that people are generally interested in soundscapes are anthrophonic sounds, which are sounds made by people, biophonic sounds, which are sounds made by organisms, usually limited to animals. Humans are counted out of that, and geophonic sounds, which are sounds made by the earth, wind and trees and such. And I just started working with my kids' elementary school on doing sound walks and soundscapes, and that requires, there's a little path called Miner's Path right next to where my kids go to school, and we go down Miner's Path, and you take these 5-minute sit-downs at benches, and you're trying to get kids to be quiet for 5 minutes is hard. But they just have to kind of shout out anytime they hear a different sound. And so we went to different locations, and this worked really well, actually, as part of a soundscape experiment, where there were locations where there was greater sounds of engines and anthrophonic kind of sounds and emissions. The less sound of animals that you could hear, of course. But you could hear things like crows and squirrels. Those were really predominant if you were sitting near an engine or a leaf blower or somebody like that who was up on one of the hills up on Miner's Path. But as you got deeper into Miner's Path, what was interesting was that when the less anthrophonic emissions that you heard, the fewer anthrophonic emissions that you heard, the more detail you could hear in terms of the orchestra of nature. The creek babbling and bugs rustling, and the bugs are coming out already, unfortunately. But the bugs rustling, the leaves blowing, the winds, the birds, the different types of birds. And that's a really important point, I think, what we'll get to at the end of this is in terms of soundscape ecology, is that the higher the rate of anthrophonic influence, the less likely it is for animals to hear each other, and thus it creates a loss in it creates a reduction in biodiversity over the long term. How have they determined this? They can't determine this. Biologists and soundscape ecologists can't determine this by going out in the woods themselves and listening for 5 minutes at a time. They have to gather data over whole populations and global populations, so they need an enormous team of not researchers but electronic devices that they plant into various locations in order to accrue all this data and analyze it. And it's impossible, they say, it's impossible for us to listen to this stuff. So this is it's a talk. A lot of the research I'm doing now is really intent on sound and listening, but it's also about the necessity to eliminate listening in order for sound to have an efficient kind of result, right? Okay, I went off the rails already. That had nothing to do with the first slide. But thank you for coming, chickadees and other lines of flight. So I'm interested in kind of new creative ways that people are using sound, maps, and birds right here. This is a research collaboration. This is the result of a research collaboration between Google Creative Lab, the Cornell Lab for Ornithology, which houses the most diverse and robust range of animal sounds in the world. And this is called Bird Sounds. It lays out these are thousands of birdsong sonogram samples on a single digital map. Organized, and the computer that they put these into organizes the sounds according to an algorithm. And so it lumps different species together and lumps likenesses together. But what's interesting about this is that it's no map of any one place. The bird sounds, they peel when the cursor's dragged over them over the sonogram impression. If I can get the cursor just over here, links right to the website. Explore the sounds. Loading 14,000 bird sounds. Here, hang on. And you can kind of play Pac-Man with it, chase around and find out what. Pleated woodpecker. We always want to end on a percussion, right? So in other words, a beautiful soundscape, right? No, not really, right? But these sound like little glitches or little sonogram impressions and traces and things like that. And tracing the cursor over in a cluster of them creates a sonic pixelated kind of wave that sounds anything from natural, right? The map is not intended to be something that you contemplate, like something that you rest your ears on. It's not intended to elucidate nature's symphony or anything like that. It's simply a computer that uses an algorithm sample board, and this is an open source code that you can make for computer-generated classification of bird sounds by allowing the computer itself to listen to the uploaded wave files and then automatically categorize them according to the contours of their vocalizations. If you kind of zoom in, well, if you could see just on there, if you zoom in, there are these sonogram impressions, which is the sound wave of the bird as it emits its vocalization, right? So this is a massive genealogical map, a tree with many offshoots, and the purpose then is to integrate new kinds of creative syntheses between programming, conservationist interventions, species identifications, biodiversity protection, and sustainability, as well as a test for the computer to make accurate classifications without the intervention of the human ear. And the purpose is to eliminate the human ear in this, right? So the experiment's intended to open up all these ideas of sound and map and place and, sound and map and place. There we go. And with Jesse Berry, who's a program manager at Macaulay Library and the leader of this project, said, "We certainly have a dream that someday you can be able to put out a microphone in the Amazon with a recorder and have all the species, not just birds, identified," right? And she wrote, "And we would be able to monitor species diversity through the automated recognition techniques," and thinks it's incredibly exciting to figure out what are those collaborations that we can make between computer science and ornithology and biology in general and start tackling some really exciting and challenging science and conservationist questions. So this is a map that is not of any place and a soundscape that is not of any ecosystem necessarily. So Cornell, like other ones, I think what was interesting about this, what got me tuned into this idea of studying sound as a method instead of sound as an object, whereas my background was in music and sound studies, I became more interested in what scientists were using sound for in terms of gathering data about the world. So Cornell uses sound not to understand the nature of what sound is, but instead as a means to find a solution to pressing social and environmental problems using the sonic as a prism. Okay, and so they're working across and through disciplines and discovering innovations regarding new technologies, human impact, environmental monitoring, conservation, ecology, evolutionary biology, and as well as different educational initiatives from primary school to professional training in sound recording, citizen science projects, people that go out and contribute these sounds to the repository. They're engaging in community and research-centered outcomes. They have a feedback to community, sustainable living, technological innovations, data management software, and analysis software for acoustic technologies. So biodiversity and environmental monitoring are not delegated to, isolated to scientific practices. Last year I talked a bit about the role of communities involved in building scientific research. And now with biodiversity loss and the imbalance in the abundance and distribution of life with ecological imbalance and with ecological stress, it's becoming more and more important, at least within my discipline of sound studies, is think of, well, how can sound be beneficial for social and environmental problems, right? And there's no other field where you can go out and have a recording session with a cow. Since sound technologies, as well as their storage devices, they're digitized, first of all, and they're automated, second of all. It used to be if you wanted to record sounds of animals or sounds in nature, you had a very limited amount of material you could record upon. You had magnetic tape, or you had files that could only have a certain amount of storage. But with increased compression and larger data storage capacities, we're capable of capturing global populations in real time. Or at least that's the goal anyway. So whereas sound recordists from as less than 10 years ago or 15 years ago would have to go out individually into the field and have large apparatuses on them and listening to different locations at different times of day. Now soundscape ecologists are going out in the field, and this stuff is cheap, so they can go and plant 300 microphones to 500 microphones in different areas and record those over years of time that there is no human ear that has the time or the patience to listen to, right? So there's this sort of open disciplinary and interdisciplinary conversation between the disciplines and between the public to make science more flexible, to make it more porous, to make it more looking at new emerging sound technologies that are really easy to use. And they're easy enough to use for kids and adults and people of all walks of life. There's nothing more to it than really clicking on a switch. But the science of it, I mean, it's interesting because soundscape, we'll hear about in a second here, soundscape usually has a kind of a contemplative dimension to it, right? And so if you read like journals of the past, like where Henry David Thoreau had celebrated the quote, the warbling of the birds ushering in the day, that's not an antiquated attitude towards birdsong. Researchers today are more accepting of what's a quote I have by a geographer, Michael Gallagher, who writes that sound is now the arrangement of charged particles in the semiconductive materials of solid-state flash memory or the magnetic surfaces of hard drives, tapes, and mini discs, which is deflating kind of the romanticism around birdsong, but at the same time it keeps up an ethical imperative, at least to appreciate what birdsong comes to signify, right? So let's listen first to the idea of a soundscape first. But before moving to soundscape ecology, I just want to give a little background on the soundscape. Last year when I was here, I talked a little bit about R. Murray Schafer, who's a Canadian composer, musician, and who was one of the founders of the World Soundscape Project at Simon Fraser University. And he argued that sound is connected to to a place, right? But that modern technology, and this is a technophobic kind of assessment, is that modern technology splits sound from its source. And he had this unique term called schizophonia around it. And that consists of sonic markers. Now, when in the design of a soundscape, you have three things that you listen for a soundscape. You have a keynote, like an embedded sound, like a river running through a mountain canyon, right? But every soundscape also has signals, which are foregrounded sounds, which are usually, for Murray Schafer, they're anthropogenic, like car horns or codified sonifications. These are signals. And then sound marks, which are a special signal that speak to a subset of a place's value. It could be anything made by humans like church bells, or it could be birds that are indigenous to a certain place. And I just put the sound of the the chickadee is supposed to be here. Where's the chickadee? There he is. So these are three separately recorded sounds. Now this is the interesting thing. These are three separately recorded sounds that I have, but the soundscape designer, they combine them in interesting ways to make points. Because you can't capture a soundscape. You can capture pieces of sound in an area, but when it comes down to it, what R. Murray Schafer said is, the soundscape designer comes forward with different sounds and combines them in unique ways. Okay. So there's also lost sounds that are sounds that are in diaries of ear witness testimony from the past. But what's interesting is that for soundscape is always a deliberate construction by its creators. That's what he wrote. He said it's a composition which may be as much distinguished for its beauty as for its ugliness. And usually when he mentioned ugliness, it had to do with the sounds of motors. Given where we are with the Castle Range and stuff like that, I thought ATVs was a good usage for that. But ATVs are really important as well, because what counts as noise For some communities, such as conservationists, for instance, would be ATVs. For the ATV community, they probably don't consider the ATV engines to be considered as noise or interference, right? And that's where Soundscape gets really complicated, because when you go to different communities, say, what sounds do you value? They might come at you with a different answer than hearing a chickadee, right? So if you go to what we learn in Crow's Nest Pass, what we've been doing with some of our sound walks is finding that the sounds of the train that runs through town is an enormous rumbling, subsonic kind of vibration. It shakes you to the core, but it's something that most people have a relationship with. So if you're going to design a soundscape for the Crow's Nest Pass, it would be almost inappropriate if you sampled people and said, what were the sounds that you heard and how do you feel about those sounds or whatever. It would be almost inappropriate to eliminate those sounds from a soundscape, the sound of the train or even the sound of the ATV, right? So this is where it absolutely becomes a political issue as well, right? So, but there's this idea that in modern industrial society, we're very sensitive to sound, right? Especially in the context of our urban life, we see a sensitivity to sound and to noise, which increases our attention to places that have reduced noise, right? So what we looked for in the early 20th century, or what people looked for in urban design, was to create resonant-free spaces, spaces that were free of sound, or spaces that were free of noise, right? So noise was this kind of invention that acoustic engineers had in order to determine what made for peaceful and psychological and community well-being, right? The best tracing of this is through Emily Thompson, who has a sound map of the Roaring Twenties in New York City, and her sound map should come up here. Although I might have, oops, where is it? Oh, there's the Roaring Twenties here. It's called the Roaring Twenties. This is a sound map of New York City in the 1920s, based on her analysis of noise complaints. And so she created a taxonomy of what constituted as noise, what constituted as sound, what constituted as rest and silence. And it turns out it's something that you should explore in your own time. I'm afraid I'm already running out of time in this piece here. But Emily Thompson's History of the Soundscape. The question then of what I alluded to just before is then what counts as being noise, right? And I kind of jumped the gun on that, but it was is the idea that if you look at urban planning, for instance, urban planning has this concept called a point of reception. And so at a point of reception, if multiple people complain about certain noises like motorcycle sounds or loud music playing, they call that a point of reception, and they introduce a bylaw to reduce those noises, right? So you can't have certain kinds of noise after 10 o'clock, or if you're in Tabor, you can't have music, what is it, ever, right? I forgot about that bylaw. But soundscapes, like so many others belonging to 20th century thought, they had the idea of the din of the city and the high quality, high definition sounds of nature, and found that with urban saturation of noises, people were looking for more sounds of nature and looking for natural retreats. Much of the design of the city came with the design of the country, right? The design of the urban was side and side with the design of the rural as a place of escape from the urban, right? So the two of them kind of emerged as two sides of the same orange through modern industrial society. So something that soundscape designers try to do is they try to, people who study noise pollution try to reduce the amount of noise in certain areas. Soundscape designers do something different. They can be hired to turn a place into its most ideal kind of sound. What we mean by that is, an ATV could be, for instance, a pleasant sound to somebody who enjoys doing that sort of thing. Other soundscapes first. I'm just going to skip one. Hang on. There's the Berlin Wall of Sound, but I'm going to skip it. So the imagination is really important and really essential to communities and the citizens who want a deeper connection to their places in cities and in urban places, right? Soundscape designers, they're not the noise management specialists. They don't calculate the appropriate decibel levels where a sound becomes noise. You can do that with a very simple decibel reader. Instead, they go to communities and they find out what people value the most in terms of sounds that make them feel comfortable. And there's a taxonomy by a researcher, Lex Brown, who writes that the list of the most popular sounds that people feel comfortable around in cities are moving water, nature, speech, music, and church bells. So what you want to do with a soundscape is you want to emphasize the sounds that a community feels to be the most resonant for them, to mask out the sounds that they find displeasurable, right? So there's one, for instance, called one was designed around this line, was called the sea organ in Zadar in Croatia. And this is an organ of church bell-like sounds and pipe organs that are played by the ocean waves hitting the side of this pier, okay? So as the ocean waves hit, it pushes the force of air up through the pipes, and you can sit in between the pipes and enjoy the sounds around you. Now, it's right near a highway, right? But when you sit in this area, the highway is masked out, right? And so it offers people a place of contemplation and all this kind of idea we were talking about before, a contemplative place to hear the vibrations of their place in a sonic form. These are all vibrations that are happening anyway, but this is something that in social studies of science and other people are interested in, something called sonification, which is turning data and movement and energy into something rather pleasant. There's a really great sound installation piece that we looked at last year. It came in and we talked last year about John Luther Adams, A Place Where You Go to Listen, where all the earthquake activity from Alaska is turned into synthesizers and a light show in a small room, and it's a choir, what sounds like, but it's actually the movements of the earth all around Alaska, right? So this is the sea organ. There are lots of these kinds of sonic sculptures that are meant to take, in Lethbridge we're familiar with this wind, but also in northern England there's the singing ringing tree, which also takes this massive wind and turns it into a musical instrument in this giant sculpture. And it's really quite moving and beautiful. The soundscape ecology is something a little different, and this is more what I'm interested in. The soundscape is something that is meant to be listened to, contemplated, and experienced, right? Phenomenological, so to speak, something that you embody, right? Soundscape ecology is different. It comes from a scientific field, or an interdisciplinary scientific field of landscape ecology, right? Which is a fundamental concept in the natural sciences. It's got lots of different definitions and interpretations. The point of interest for landscape ecology is in the pattern or the structure in a land's abundance and its distribution of life, right? And that could be more anthropocentric, it could be more planning-based, it could be more focused on biological processes, it could be based on non-anthropogenic processes. And the field became very popular in the 1980s of understanding the spatial configurations and the time patterns that landscapes give to the abundance and distribution of different ecosystems, or how a landscape could change from one ecosystem to another, and how those ecosystems are interdependent with one another, right? So there are various ways of doing this. Mostly it was through digital imaging, remote sensing, geographical information systems, capturing again the idea of a whole population, seeing how a highway near a place like this would interfere with the abundance of life and the distribution of life in a landscape, right? But mostly it was discovered that you needed more elaborate technologies to study this kind of place, and that's where soundscape ecology comes from. Soundscape ecology, in the meantime, tries to identify within the distribution on a landscape ecology what types of sounds interact with each other, right? It kind of grew organically from landscape ecology. They realized that, and one person I talked to in my primary research and sort of the on-the-street research that I'm doing with bioacoustics researchers at the University of Alberta, is discovering that they conceive of animals and plants as being sonic first, then visual second, right? So they consider animals to be defined by their acoustic properties because that's how they identify themselves to one another outside of the boundaries of their own bodies, right? So soundscape ecology is interested in a whole different types of questions as opposed to soundscape or the traditional study of soundscape. They make new possible relations between spatial and sonic and social. And soundscape ecologists, they study all kinds of different things. They study cities, they study the urban, the rural, They look at high definition data capture regarding the dispersal of organisms and the interactions between biophonic, geophonic, anthrophonic emissions. And soundscape ecologists aren't interested in sound as an aesthetic object. They aren't interested in what it can do for your feeling of comfort, right? So they're more interested in the sonic emissions and how they parse out and how they interfere with one another and what nature's orchestra is, not for the enjoyment of the human ear, but for understanding the richness of biodiversity and the necessity for it for sustainability, right? So soundscape ecology, they don't, it's not like they abandon the kind of the contemplative or the beautiful aspect of it. They incorporate that into their mobilizations and their knowledge syntheses. So in the case of science, they really like, instead of trying to immerse you in an environment and make you feel instead of see, they really like the idea of the visual, or rendering things visual. This is a soundscape, for instance, of central London, right? With this is a massive soundscape project that was launched in the UK some 10 years ago or so. This is one of the earlier soundscape ecology projects. Mainly interested in techniques of representation, right? Namely because of these rapidly expanding data sets that they have access to, the newness of the field, the new ways of recording. There's no established way of doing this, but they use these automated recording units that, what's fantastic about these is that because they use automatic recording units, they plant them into different areas, mostly in the rural, that you can only get in by fat bike or by helicopter, and they plant these machines and leave them for months at a time, come back and collect the data. So they're not interfering with the ecology itself, and they don't have to be there for it, right? So they use all these virtual mapping, and then when they visualize it, they really like the notion of visual. This is a noise map of London in the meantime. So this is like the noise pollution specialist. They have a decibel reading chart. And you can see that in, of course, more industrial parts of town, silence isn't valued as much as when you go into where the real estate is more expensive. You get levels, decibel levels that are much lower, right? So soundscape ecology is conducive with the anxiety around our environment, around noise pollution on a global scale, the role that humans have in interfering with the balance of the ecosystem. Some research teams use these noise mappings like this one by reading city decibel levels according to color-coded legend that identify noise, hotspots, right? And then apparently in the US, some researchers are finding that an estimated, at least, these things can only be estimates, a supposed 83% of the land in the US is about 2/3 of a mile from a road. So conservation officers team up with acousticians and sound ecologists to reduce the presence of helicopters in the rural, reduce air traffic, planes, and other means of transport, especially transporting tourists into natural landscapes. An area of research which would be really important for this would be Banff, for instance, with their recent necessities to close Banff because of the overpopulation of tourists there. So there are these high levels of noise that inspire scientists and researchers alike to do these little aesthetic and fun artistic things, like locating the, quote, the quietest square inch on the earth in the US that has no anthrophonic interference for up to 20 minutes at a time. And that's what one soundscape ecologist has found. He said, I found the 1 square inch in the United States that has no anthrophonic interference for up to 20 minutes, right? So whether that's, it's not objectively, there's no evidence to say that's objectively true, but the point is made, right? So conservationist interventions, if they're successful, they have to transcend local interventions, local projects, and motivations behind, there has to be more incorporation of the public with this stuff. So you also have to, you can't just make it science maps on the web, right? There has to be some element of popular culture with this as well in order to get people interested, including the very noisy Global Soundscapes IMAX film, which is coming to the Calgary IMAX in the next year or so. So trying to find whole global populations of species, places, and ecosystems also requires a kind of a new popular culture type of selling to the public, as well as getting people, how do you raise awareness? We talked about this last year a little bit too, as the most difficult to measure is measuring awareness and increased awareness. So there's an assumption that the popular culture will takes on these kinds of research initiatives do a great benefit for the public, but again, that's not something that's necessarily been proven. But if soundscape ecologists are interested in whole populations over time, it's very necessary to use technologies that listen and recognize patterns like the declining sonic signals emitted from organisms. Research teams don't have small samples anymore. They have up to 35. There's one research team that has 35 samples from one recording location in Tippecanoe County in Indiana. They've indicated that places with more anthrophonic influence are drowned out by drones that contain, they say, there's no information in a machine or a drone uttered, and that creatures can't hear each other and reproduce, and thus biodiversity loss, right? 300 microphones being used at a time to record certain areas, one in Germany where the microphones are timed to 1 minute of sound in the environment every 10 minutes, after which the data is processed by computer with over 120 terabytes of storage. And this is the thing, this is from a research trip for one of my informants, Aaron Bain, and his research team, where they take these, in the backpack, they have automated recording units and take fat bikes, which fat bikes was supplied by an NSERC grant, to help people get into swampy areas that are otherwise very inaccessible. They sometimes take ATVs. ATVs are very useful for these research teams because they just can't get to these locations otherwise. But if it's a really exciting day, is when they get the helicopter and they get dropped into these locations. They drop these recording units into swamps and such, and leave them for months at a time, press record, and then record these things. This is actually taken from one field trip in particular, that they're looking for nighthawks. They trap them, and then they put small microphones on their backs. Stapled. They put them on. They tie them in between their wings, and they track their sonic emissions as they migrate. Right, and the only way to access these places. What's interesting is the only way to access these places has become very intense with the research process, which is to go to these places, camp out in the backwoods, and then leave and come back months later. Okay, so while earlier recordings in conservation biology were used to identify individual species, what they're doing now is they're trying to identify the ecology or the orchestra of birdsong with sounds in its environment, and how the two are informing each other. Okay, so this is where the idea of automated recording units comes in, or they call them autonomous recording units, that are dropped in and listen for the researchers instead of the researchers listening themselves. They're accessible by all-terrain vehicles in these locations. They're reachable only by helicopter or ridden in on fat bikes, which are these fat bikes are these off-road bicycles. And the placement in them, the actual, like when we talked earlier about the Croatian, the sea organ in Croatia, there was a sense of embodiment there, or being with that place. The embodiment and the being with the place now is in the process of getting the recording unit out there for the purposes of data collecting and analysis, right? So reducing your presence is important to research teams, and bioacoustic soundscapes and acoustic soundscapes in general, they're more internal, they're more intertwining, they're less on producing an atmosphere for people to listen to than to listen to the emissions from organisms, okay? So part of the repertoire in this area is that it radically redefines the sound object of a soundscape, given the fact that the ARU is capable of capturing such an enormous range of material. It's terrifying. One informant that I had mentioned that he said that there's no way to listen to that much data. There's no time for it either. I wouldn't characterize what we do as part of a crisis discipline, but for conservationist efforts to be facilitated, we have all the data recorded and analyzed quickly using algorithms for identification. The machines can listen for us now is remarkable, and I can say with all comfort that we've reached a very high level of accuracy rate at sound identification and intervention. The idea of a crisis discipline is kind of what I like to meditate on here, because crisis is often introduced, at least in the social sciences, and we'll talk to the social scientists for a sec about crisis, is the idea that discipline must make a turning, or it's important, or there's a point of readjusting one's lens towards a different set of tools to understand the world. Crisis discipline was taken as part of conservationist biology to say that the data collection, analysis, and distribution of our research is too slow. It's so slow that by the time the research is out, we've lost a population, right? So crisis discipline was introduced as an idea of making quick methods and being creative and DIY and getting on your fat bike, getting out and recording the stuff as quickly as possible, as much information as possible, and getting it out there as quickly as possible. But because you still have to respect the 8 to 14 month peer review process, right? So that's how they get around it, right? So what are the usages are there for? I mean, and we talk in great deals. That movie I showed you, the little movie clip I showed you before, talked a great deal about sound as an external thing, but they also looked at the human voice too. They go inside. And that's kind of what I'm going to end on, is this recent study of biologists who are looking at orangutans' vocal folds that allow it, under controlled conditions, the capacity to voice. And they use these soundscapes of the internal world to find out some correlation between human agency and orangutan agency, right? And they found it, they think they found it, although of course it's being contested already, in the mimicked grunts that are emitted by researchers as a form of primal communication. So orangutans can manipulate the tones and the timbres of its own grunts free from external stimuli. The neurologists call this a freedom from immediacy. And when they put a sonogram sample of an orangutan's grunts, they see that they're in correlation in conversation with the scientists that are grunting along with them. This is one of those, again, a crisis discipline where a team of researchers say, well, your job is to grunt at the orangutan, and then we'll record it, and you have a conversation with it, and they called these grunts Wookiees, right? So the central concept of volition then was a capacity to simultaneously anticipate your own action, which is an intent, and to reflect on those actions, which constitutes agency, at least for neurosciences. So this is these new ethnoprimatological methodologies, which is researchers that talk to primates, right? Where a researcher engages in a playful communication with the research subject. What it does in that case, it frees a researcher up to where they don't have to listen to what the primate is saying. They can rely on the technology itself to capture it, visualize it, and they can identify it later, right? So that actually frees them up to be more playful in their methodologies and more kind of daring in their methodologies, right? So the kind of sense here that we're getting here, what I'd like to kind of just end on is the idea of a sense compression. You know, there's been a great deal of fear, not fear, but if we talk about the world of sound, people will often talk about how the MP3, for instance, doesn't have the warmth of like vinyl, you know, or the warmth of an audio cassette. It's because an MP3 is compressed to eliminate all infrasonic and supersonic sounds, everything that the human ear can't hear. But a vinyl record produces rhythms that you can perceive with your body, as well as ultrasonic emissions that you can still perceive, but not necessarily directly. But in this case here, sense compression for the scientific research is extremely important with the amount of data that they have to gather, the amount of research tools that they need to do, and the amount of time they need to do it in, right? So again, the idea is what happens when we use sound not as an object of analysis, but as a method for trying to understand a very complex orchestrated world, right? Soundscape ecology provides this kind of interdisciplinary social sciences with a new logic for accessing the rate of global environmental change. There are large data sets with sonic information that can be recorded, stored, analyzed, visualized without recourse to human-centered forms of listening. And there's certainly no intention to discard the philosophy that underlies listening. There's just more of an openness that requires our immediate attention. And that's where I'll say thank you for listening to my first public speech in about 8 months, I think. Thank you. I'm at Athabasca University now. If any birders are interested in contacting me or giving me your contact information, I'd love to know about what drives you in that area and where your interests are. Thank you very much for listening.
Thank you.